Hello everybody, my name's Debbie Roberts and I'm a course director for Transport Engineering in the Department of Engineering at Staffordshire University. I'd like to welcome you to this Girl Guiding Midlands Fascinate Paper Aeroplane Challenge. So just to give you a bit of background about myself, as I said, I'm a course director in Transport Engineering at Staffordshire University. I've been an academic here since 2008. And before that, I was actually a student at the university. I was awarded the Queen's Award for Voluntary Service in 2012 as a member of the Bolton Paul Heritage Project, working on historic aircraft of a company called Bolton Paul, who were based in the West Midlands. But I'm also a former Brownie, guide and young leader, and I worked within the Lapley division. So not only am I an engineer, but I've also been involved in guiding for a number of years. I wanted to introduce you to some of my team members that I work with on a daily basis. As you can see from our pictures, we're all engineers, we're all different ages, nationalities, but we all have one thing in common. We're all engineers who are creative and problem solve on a daily basis as part of our careers. And you might have an image in your head of what an engineer looks like. You might be thinking high vis, you might be thinking hard hats. But no, all of these people here are engineers. Occasionally some of us may wear high vis or a hard hat, but on a daily basis, we're working in offices, we're working on sites, we're working with students. So it's quite different to the image some of you may have had in your head. So what is engineering? Engineering is the application of science and maths to help solve problems, and it goes back a long way. Engineers actually investigate how things work and they find practical uses for the scientific discoveries made. It's scientists and inventors that often get the credit for the innovations, but it's us engineers who are instrumental in making those innovations readily available to the world. So some of those key skills you need as an engineer and that you're going to need to employ today are critical thinking, collaboration and communication. Without those, it's difficult to be creative and innovative, and that's really what you want to be doing. So as part of this challenge today, we're going to be looking at the design of paper aeroplanes. So you're going to need some sheets of A4 paper, you might need a ruler, and you're going to need some space to fly them. But that's all you're going to need. You don't need to have much to get involved with paper aeroplanes. So have you ever wondered what makes an aeroplane fly? We know from our experience that some paper planes fly longer and better than others. But we need to think about why this is and what are the design factors that might influence a paper aeroplane flight. And those are some of the things we're going to be thinking of over the next part of this video to sort of concrete in and set our ideas about what might assist us in our design of our paper aeroplane. So paper aeroplanes actually go back a long way. The first sort of folded paper gliders were seen in ancient China and Japan, and there's evidence of them existing as far back as 500 BCE. And if you think about Japanese origami, that was actually dated to the 12th century, that was the art of folding paper into different shapes and models. In the late 1700s, hot air balloons were built partially out of paper, and it's some of these principles that we need to have an understanding of in order to help us make better aeroplanes and paper aeroplanes. So paper aeroplanes are quite a popular hobby, and there's different ways to build model gliders and aeroplanes. Traditionalists use only a sheet of paper, an A4 sheet, for example, whereas others might cut, tape or paste their models together. So we're asking you in this challenge to stick with traditional methods for now. So only use a sheet of paper and only use a ruler or a scissor cut to help with your folding. The Guinness World Records team and the Guinness Book of World Records has multiple paper aeroplane categories. So flight duration, the longest, the distance it's travelled and the wingspan. The largest paper aircraft had a wingspan of 18.21 metres. It was constructed over in Germany in September 2013. We're not expecting the biggest aircraft today, but just think how you might meet those technical challenges. So how do paper airplanes fly? It's all because of the air, the stuff that's all around us. So air, we know, is made up of molecules, and those molecules are a gas, and they whiz around us, and essentially how that air interacts with solid objects creates our flight. So if we place our palm flat down and we're moving it through the air, it moves quite easily. If we were to place our palm forward and repeat, while it's still fairly easy, you're going to feel slightly more force on your hand. And that's due to our frontal area, the area that makes contact with the air. So the larger the frontal area, the more force acting against our hand. So how easily an aeroplane moves through the air? Its aerodynamics is the first consideration in making it fly. And aerodynamics we use a lot in the aircraft industry. We also use it in the automotive industry. So it's quite an important field to have there. As with real aeroplanes, it's those forces acting that enable the paper plane to stay in the air. So now I want you to have a think, and I'm going to ask a question. What do you think those forces are? So what you might want to do now is pause this video so that you can think about what those forces are. So what are the forces that enable the paper plane to stay in the air? So hopefully you've had a bit of chat about that, and this is the first of the forces that you may have come up with. And you may have called them different names, and that's okay, but the first one is thrust. So that forward force, when we throw the plane forward, the thrust force is what moves it through the air. And it's acting in the same way a real aircraft's engines would. And it's a positive force, so it assists us in the flight, it's assisting us in moving forward. The second force you might have come up with is lift. And that acts upon the wings and the body of the aircraft. And it helps to keep it up in the air. A larger wing surface area can increase our lift. So lift is another one of the positive forces we like to see. You might have mentioned gravity, or you might have said weight or mass. So gravity is the mass and the gravity working together to pull the aircraft down. We know that the gravity on Earth, or we might know, that gravity on Earth is 9.81 meters per second squared. We know that that keeps us on the planet and against the surface. If we were able to fly our plane on the moon, ignoring some of the additional complications around that, the gravity force is weaker. It's only 1.6 meters per second squared. And that means that actually that would have less of an effect on our aircraft. Gravity acts against us flying long distances because it wants to pull our aircraft down to the ground. The final of those forces is the drag or the resistance. So you might have called it resistance, you might have not called it drag, but it's acting in the opposite direction to the thrust, and it's slowing the plane down. If we've got a big frontal area, or we have a tailplane, that can increase the drag. The tailplane may additionally provide us with some more stability. So if our aircraft is flying from side to side, the tailplane might help. The higher the drag, the greater the resistance to that forward movement. So thrust and lift are the forces we want to encourage. We want to minimise the effects of gravity and drag. So we need to remember that as thrust and lift move that plane forward and up, those opposing forces are at work too. So the drag and the gravity will be trying to pull the plane backwards and down. resisting that forward and upwards movement. So we want a balance of forces in order to make our flight last as long as possible and to go as far as possible. So we need to bear in mind that our initial thrust comes from the muscles of the pilot launching the plane. But after that, a plane actually acts like a glider, and long flights are going to occur when our four forces are relatively balanced. There are a lot of different designs out there for paper planes. You might have some ideas of your own, but they all rely on a different balance of forces. So planes that are more dart-like need longer starting thrusts and we need to throw them a little bit harder and further. Longer flights tend to have more lift, so they might curve up and then glide back down. So it's about balancing those different forces. The Paper Aircraft Association lets us know that if we were to throw a paper aeroplane in space, it's not going to fly in the traditional sense we might see on Earth. It's actually going to float in a straight line, and they've actually took paper aircraft up into space to see some of these phenomena. What we need to bear in mind is quite often when we're involved in a design process or engineering, we need to consider safety. And for example, with a bridge, we might want to take a certain load. We need to make sure it will work beyond that, so we introduce a safety factor. There is a trade-off there though. The stronger we make the bridge, the more it might cost. And therefore we have to balance safety and costs, and it becomes a trade-off. So we need to have a think about what our trade-offs might be with our paper planes. If we make them larger, do they have a further flight, or is that weight too much? If the wings are particularly wide, are they quite good? Do they produce a lot of lift? Or is the paper going to bend and crease? So there's things we might need to consider. So you might want to have a think now about what might change how your aircraft performs. So you might want to pause the video here and consider in your groups how our variables might be, what might change how our aircraft performs. So thinking about our variables, you might have come up with some of these. So what might change how our aircraft performs? You might have considered the weight of the paper. So different papers have different thicknesses. So if we use some normal sort of printer paper, this can be quite thin, it folds quite well, get a nice crease. If we were moving on to thicker card, it might not fold as well, but it might be more sturdy. And we need to think about those considerations. It will also have more weight. We might need to think about the changing mass of the aircraft. So the larger the sheet of paper, the more mass an aircraft might have. If we're using thicker paper or card, that might change things as well. We also need to look at the centre of mass. So where does the aircraft balance? If it's balanced quite towards the front, we might need to hold it more towards the front when we fly it. Whereas if there's a lot more weight at the back in terms of folds and that, it might be we need to hold it slightly further back. So we need to learn about our aircraft. Wing loading, so the mass of plane and the surface area of the wing coming together. The larger the wing, the more load we might have it on it. But that means it might be more prone to bend, so we need to think about that. Paper size, the larger our sheet, the bigger aircraft, but that might have a downside as well. Smaller sheets of paper might mean that we can't get our folds in as well, or we get multiple thicknesses of layers, and the quality and accuracy of our folds. So we want our folds to be quite neat. We want to possibly use a ruler just to make them as crisp as possible, because that's going to help, whereas a slight bend might cause our aircraft to behave unpredictably. So we need to have a scientific method for testing. Whenever we do tests, we need to think about a scientific procedure to stick to. This helps us make our tests consistent and fair. So what we need to think about now, and you might want to pause the video to have a think about this in your group, what might we want to consider but when testing our aircraft to make sure it's a fair test. So some of the things you might have considered in making it a fair test is setting out an area to test, all testing in the same location. You might want to set out a start line and say each person needs to place their toe at the start line each time, so we're always throwing from the same place. We might want to keep the same person throwing each time, or to keep that consistent, or we might consider how we throw and all agree to throw in the same way. We might want to consider throwing inside if we've got room, or outside. We have to think about the weather conditions. If it's wet or there's crosswinds or gusts, they can influence. If we've got a lot of trees around, we might want to be inside if there's enough space to fly our aircraft. And we might want to repeat our flight more than once to see that it's consistent. So we might say we'll repeat each flight 3 times and work on an average. So just to give you a starting point and some ideas, here are some planes, and these are from a website called foldandfly.com. Just gives a lot of examples of aircraft. We probably all have in our head a traditional paper aircraft, sort of dart type shape, but there's so many more out there, and it's just thinking about how we might get involved and use different air designs. So this one is probably one of the most traditional. This is the dart. So we fold the paper in half, we then fold in the corners, fold in again, fold in half, and then fold the wings out. The dart flies quite far and fast, and we have to watch out for that pointy nose when we're flying. So thank you for having a look at this and taking part. I hope that this has given you a bit of inspiration to design your own paper airplanes and test them. And I'd love to see your groups sharing the aircraft you've made out there into the world and sort of looking at how you might improve them further. Thank you very much.